Okay, we're going to be doing leetcode 1112 path sum. So you're given the root of a binary tree and an integer called target sum, and you're supposed to return true if the tree has a root to leaf path such that adding up all the values along the path equals the target sum, right? So you're supposed to return true. So basically what this is going to be is you're simply going to do, this is a top-down DFS solution. So you're going to be subtracting from here to here to here to here, or to here. Then if after subtracting here your result is equal to 0, you return true, right? So let's do it in the diagram. So this is our sample tree, and our target is let's see. Oh, I forgot to circle this. That's our target is 20, right? This is our target sum. So we start from this position, right? So we say 20 minus 5. So we have here our counter, right? Which is set to 20. So we start 20 minus 5 here. We get 15. We move our counter to here. Sorry, we move our counter to here. We say 15 minus 4. We get 11. We move our here to the leaf node. Then we check 11 minus 1, is it equal to 0? No. So we move back up right here where our answer was 11, right? Where counter was now 11, and then we move this down here, right? So 11 minus 11, is it equal to 0? Yes, it is. So we return true, right? So let's code this out. So our edge case is root is none, right? So if root is none, then we simply return false, right? Because our target sum won't equal any value, right? So next thing is we create a top-down DFS function to solve this, right? So our function will be DFS, and it will take a node and some val, right? So when we are at the leaves, this will be if not node dot left and not node dot right. In other words, these are empty, right? If node dot left is none and node dot right is none, then we check if the value at node minus current sum val is equal to 0. So if node dot val minus sum, no, if sum val minus node dot val is equivalent to 0. If it is, we return true. But okay, we return true. Yeah, right. Then here we are at non-leaf positions. So what we do is we say if node dot left, in other words, if node dot left has a value, we do DFS node dot left and then sum val minus node dot val. Then again, if node dot right, DFS node dot right sum val minus node.val. I had to fix this, right? So this will return true if it finds this condition, it will simply return true. Otherwise, it will just keep on moving on, right? So what we're going to do here is we're going to initialize our result variable, right? So result will equal to, we'll say false, right? Actually, we'll, because if we say false and then we do DFS, if we do false and then we do DFS root target sum is equal to result is equal to this. If there's no true value, it's not going to return false either, right? So what we're going to do is we're going to make this we're going to make this that, and then we'll leave it like that, and then we'll change this to return. We'll change this to result at index 0 is equal to true. So we'll be basically changing the value of this result, right? And then here we simply return result at index 0. So the issue we face with just using a normal Boolean variable is that this function will return either true or none, right? It won't have a return type. So it's best if we simply have this this variable here for the result. So when we return this, should work. Voila, and this takes O of n time in the worst case, and the recursive recursive calls take O of n space complexity. There's no better way of doing this. So yeah, and this, come on, give me that. I need that 98. So anyways, this is the solution. Let me see, maybe if I initialize this up here. Okay, anyways, this is the solution for the problem, and good luck with solving your interview problems.